Hello everyone, today we'll talk about the problem maximize happiness of selected children. We're given an array of happiness of length n, which is the happiness of every child, and also a positive integer k, which indicates how many children we can take from that list. Now we want to take kids that are as happy as possible. However, when in one step we take a single child, then all the other children that remain on the list will become less happy. Their happiness will decrease by 1. However, it never can become negative, so if the child is already not happy at all, so their happiness is 0, then that happiness doesn't drop any lower. And we want to maximize the sum of the happiness value of all the children that we select. Here in the statement you have that they are standing in a queue, but it's not really a queue. We can take any child we want from the middle, from the end, from the beginning. It doesn't matter. So we want to just select them in such a way that the sum of their happiness is the greatest, and after every step the happiness of all the remaining children reduces by 1, never becoming negative. Now the main observation here that allows us to solve this problem is that at every step we might as well take the child that is the happiest of all the remaining children, and that means that we can, after sorting all the children in descending order, so in Python we have to pass reverse equals true to the sort method, we can just take the children one by one from the most happy, and after the k steps, then we'll be taking all the children, all the k children that were the happiest at the beginning. And of course, for the first child we get their happiness, for the second child their happiness -1, and so on. Now, what we might not be sure about is if indeed the k children that were the happiest at the beginning are also the k children that are the happiest if we go step by step, so after reducing those happinesses. But it's easy to see that it is indeed true. That's because if child I was better than child j at the beginning, right, so their happiness was greater, then after, let's say, s steps, their happinesses will be this. Maybe they will be equal, and this will just be 0 and 0, but in that case it also doesn't matter who we take. So in other words, there is no situation where we'll get a better result by taking a child that at the beginning had lower happiness, because while we run our algorithm, along every step, they still will have happiness that's not greater than the happiness of the child that was happier at the beginning. So indeed we can just take the k happiest people at the beginning, and we can simulate it simply. So just go through all the children and decrease their current happiness by the number of steps that we've made previously. Now it's also possible, but in this problem it doesn't really help, to notice the fact that of course because typically when we have those penalties, then we might just go step by step, and sometimes it works, such as in this case. Sometimes it doesn't work, but we can utilize an observation where the sum of penalties that we get, so the sum of decreases of happiness, is the same no matter what order we take the children in. So it's not the case here, because the happiness value cannot become negative, right? So if children are not very happy at the beginning, it's possible that we just take 3 children with positive happiness, and then, let's say, 2 more children, but they will have happiness 0, because they were so unhappy at the beginning that their happiness would now be negative if we were to actually decrease it by the full number of steps, so it's all zeros. So the full penalty indeed may depend on the original happiness, but in some other problems it may not depend on that original happiness. So if the happinesses could become negative, we could just take the sum of k biggest happinesses at the beginning and subtract the sum of all the penalties, and that sum of all the penalties would of course be k times k minus 1 divided by 2, which is simply an arithmetic progression. But in this case we cannot utilize that optimization or that observation. And of course, when it comes to implementing it, we can implement it with just a normal for loop, or we can, since we're programming in Python, do it a little bit simpler. So we want to take k maximal happinesses, and since we want to subtract from children their decrease in happiness at the appropriate step, then well, we just have to, for the 0th child, subtract 0, for the first child, subtract 1. So just let's enumerate happiness, so get the index and value at every position. And now from that value we subtract the index. However, if it would be negative, then no, we want just to have 0. And at that point, this list is still sorted. And now we can take the k greatest, and the sum of those is indeed the result.